Live Linux forensics. So what's that about anyway? I'm going to tell you how in a few minutes time you can determine with some level of certainty if someone hacked you or not. So, can you figure this out? Can you minimally disturb your subject system? And can you automate this process with some shell scripting? So why should you care? Right? So someone calls you about a suspected breach, and you need to figure out pretty quickly if they were hacked. You want to do this quickly so that you don't avoid, or so that you do avoid any further harm to their system. You also don't want to destroy any evidence, and if it's a critical system, you don't want to take it offline while you try to figure it out. Some of you might know me. Some of you might wonder who this extremely handsome guy is. I'm a digital forensics professor. I teach at Bloomsburg University of Pennsylvania. I've been programming since I was 8, in assembly since I was 10. Also been known to hack electronics since I was around 12 or so. Used Linux for a long time. I actually have my own version of Linux called Deck Linux. It runs on the BeagleBoard, BeagleBone, and similar things. And I've written a couple of books. I wrote a book on low-power hacking devices last year. Wrote a book on Linux forensics that came out this summer. And I have another book on USB forensics that's coming out maybe around the end of this year, which is why it says insert cool cover art here. Because, I think that the cover art on the forensics book's pretty good. But all right, so what are we going to talk about? We're going to talk about how do you open a case, how do you talk to the users, and from there, how do you mount known good binaries? How do you minimize the disruption to the system? How do you collect data? What kind of data do you want to collect? How do you automate all this stuff with scripting? And some next steps if there actually was a breach. So the first thing you want to do is open a case. So the first thing you have to do when you open a case is figure out what are you going to call that case. Well, if you don't know what to do, use the date. I mean, you're probably not investigating multiple Linux systems on any given day. If you are, maybe you have some problems. Maybe you need more people in your organization or better security overall. So what you probably want to do is create a case folder on your laptop, on your forensics workstation. And you also want to start making some entries in your notebook. So I like to have, some people think this is old school, but I like to have a bound notebook with numbered pages. Now, if you can't find one with numbered pages, you can easily number them yourself, assuming, of course, that you know how to count, right? These are easy to carry. They're hard to insert or remove pages, so if anyone ever says, oh, you added that later, you can say, no, I didn't, or if they wonder if something's missing, you can say, there's no pages missing here in my notes. Also, they don't need any batteries. Right, so that's a plus. So once you've opened this case and you've started making entries in your notebook, the first thing you want to do is talk to the users. Why? Well, they know the situation better than you. They have some good context for the situation. Other reasons. Why do you want to talk to the users first? You might be able to avoid doing any of the fun technical stuff because you might talk to them and find out, oh, well, someone was running this script from this little class that he took last week and nobody else knew about it and nothing really happened here. Right? If you do talk to them and it's not something that simple, you might want to ask questions like, why did you call me? What do you think happened? You called me for a reason. Are there no internal experts on Linux at your organization, or perhaps there's some sort of policy where they say, if we suspect a breach, we always get an external person to come in and evaluate that. You know, why do you think there was something? Everything you know about that subject system, what's it used for, what operating system does it run, who's typically on it, etc. Right? These are the kinds of things you want to get from the users. Once you've finished interviewing the users, you want to start thinking about actually touching the machine, actually doing the fun stuff. So you want a USB response drive, and what's going to be on this response drive? Well, one thing you definitely need are some known good binaries, right? You don't want to be running possibly Trojan binaries on the subject system. At a minimum, you're going to want to get bin and sbin for the same architecture. So if they're running 64-bit Linux, grab those. If they're running 32-bit Linux, by the way, does anyone here still run 32-bit Linux? A couple of you? Okay. I mean, it was available for Linux. 64-bit Linux was available before you could buy the stinking chips. So I'm always a little surprised that people still run it. But anyway, grab a compatible architecture. You might also want to grab user sbin and user bin, user lib, if you want to run a couple of extra tools that you don't really need for this part. But you must, no matter what you grab, it has to be on some sort of an ext file system, either x2, 3, or 4. And the reason for that is permissions. Right? You can't put it on a FAT file system and have it maintain all the execution permissions, etc. It's not going to work for you. Definitely not for system binaries. So you might decide that you also want to have a bootable Linux. Now, that bootable Linux is probably going to have to be on another partition because most of those install on a FAT partition. It also has to be the first partition. So you can't say later, oh, let me add this to the end of my drive. It's probably not going to work. So you have to make that decision up front. If you go to this link here, linuxforensicsbook.com, we have a bunch of videos that go along with this Linux Forensics book. You can watch them. They're free. I'm not trying to sell you anything. But this video actually goes through this process and shows you an easy way to develop one of these response drives inside of a virtual machine so that you don't have to tie up your nice computer forever. Because anyone ever installed SIFT? Who's installed SIFT? Does it take a long time to download all those packages? It can take hours. So why tie up your whole machine? Just put that sucker in a virtual machine. So if you watch that video, it'll show you how you can mount a physical thumb drive inside a virtual box and do it that way. I find it a lot more convenient. All right, so you've got your thumb drive, and now you need to mount your known good binaries. So how's that going to look? You want to insert your response drive, and then you need to exec your version of bash. Not the one that's there. That would be a bad idea. Then you have to set your paths to point to your binaries, and only your binaries. Then you need to set the LD library path so that all the shared libs are the correct ones. And you want to run all of your scripts as bash followed by the name of the script. Don't have shebangs on the first line of these scripts, right? Because what is that going to point to? It's going to point to the Trojan ones, right? Don't go through all this work of loading known good binaries and then run the Trojan ones in the end. It's a lot of effort for absolutely nothing. All right, so what does that look like? Let's see. We might have audio, or I might just narrate. We'll see what happens. All right, I think we have scratchy audio.
So I have my subject system here.
Right.
Now it might.
That's a little bit too scratchy. I'll just narrate. So here I've plugged in my drive, and now, there we go. And now it has auto-mounted this file system because it was an X4 file system. So I'm going to pull up a shell, and this is on the subject system. By the way, you might have noticed warning messages, and the reason for that is because this system has actually been hacked. So now I'm changing to the directory where I have my known good binaries, and I exec my bash shell, and now I'm going to set my paths. So I'm going to use a little trick that you can do in the bash shell, where if you take a command and you put it inside of parentheses that follow a $, it will run that command and then put the result in that place. So you see where I have $PWD repeatedly. It's going to put that huge path to my thumb drive repeatedly in my path, and I do the exact same thing for the library. And this is just a quick test running ifconfig to make sure that it's working properly. So now I have some known good binaries. I want to start doing some forensics. Again, I want to minimize the disturbance to my system. You know, you're always going to change it a little bit, but we want to try to minimize that as much as we can. We never, ever want to write to the subject media, and we want to try to minimize our memory footprint. So there are two basic options here. You could either write everything to your USB drive, or you could send it over the network. Right? So sending it over the network, I think that this is better than using the USB drive, primarily due to caching. If you know anything about USB and flash media, it is very slow for writing operations. So it is highly cached. So if you don't do this, if you don't send stuff over the network and you think, I'll just put it on my thumb drive because it's super easy, you might consume a lot more memory and lose some evidence more so than you would think. So if you want to send it over the network, you can use your old friend Netcat. By the way, Netcat or NC on most systems are exactly the same. It's just alias. Sometimes I hear people having this debate, should I use NC? Should I use Netcat? It's the same thing. Check it out. You can actually figure that out on most systems. So what you want to do is create a listener on your forensics workstation for log information. So I'm going to run a bunch of commands, and I'm going to pipe the output, which I call log information, to my forensics workstation. So I will create a listener as well on my forensics workstation for files. Now you might see a suspicious looking file, and you might want to send that, or you might even have something as simple as a password file that you want to send, etc. So the way that the file listener works is I have a listener that just sits there and it waits for someone to say, I'm going to send you a file, here's the file name. Once it receives a message like that, it spawns a new listener to actually receive the binary data. And that's just a little bit easier and cleaner. So how do you set up a listener? Well, you can run Netcat, and how many of you have used Netcat? I'm guessing, yeah, a lot of you have used Netcat before. So if you want to set up a listener, you just say netcat-l, and the -l option will say, I want to listen, you give it a port. And by default, it will listen on all of your IPs on that port. The -k option is meant to keep that connection alive. Typically, if I send a line to my listener, it says, oh, thank you, and I will terminate now. Right? So we want to keep it alive during our test. So from the subject, you have a command, and then you can pipe it to netcat, and then give it the IP of your forensics workstation, and then whatever port you used. And we will use shell scripting to automate this. Now, some of you might like Python. Who likes Python? All right, I like Python too. All right. But for this purpose, Python is going to use a little bit more memory. So I want to minimize that disturbance. So I'm actually going to use shell scripting instead of Python for this. So I'm trying to automate this listener. So I have a simple shell script here that runs on my forensics workstation, and I just run it, and I give it a case number. So you can see the usage statement is shown up here, and then I say, did you give me less than one argument? If you did, I'm going to tell you, hey, you messed up. I'm going to show you usage. Otherwise, I'm going to say I'm starting a case. If the directory doesn't exist, that's the if not -d $1, then I create it. I create a log listener. Again, I use NC with the -k option to keep it alive. And then I send all of this information to a file called log.txt. And notice I have that run in backticks, and I background it with the ampersand. And then I just print out a little message saying, oh, guess what? I just started this log listener. Okay. I also start the file listener, which is a separate script right at the very bottom. What about the client? So on the client side, I have a little script that sets a couple of environment variables. Now, I will admit this is not the world's most sophisticated script, all right? I could have done this different ways, but again, remember the goal here was to be simple and use the least amount of memory. And that's why I have just a whole bunch of if-then statements, where I say, did you give me an IP address? Because I need at least that. And I set things. If you didn't give me things, I set defaults all throughout this script, and that's it. It's just setting these environment variables. Part 2 of automating the client side of this is to have a command or a script that will run a command and send the output across the network to my forensics workstation. So you can see from the usage statement, how does this work? You just run the script, and then you give it the thing that you want to run. What does it do? It just prints a little banner. So the line at the end might look a little involved, but if you decode it, here's what it's going to do. So I'm going to say echo-e, that means please interpret things like the \ns. So I'm saying sending the log for, and $@ is the full command that was passed to the script. At, and then the date, and a couple more plus signs, and then a new line. And then notice that I'm using my little trick again. I have $, and then a command in parentheses. Well, that command just happens to be $@ everything you passed in. Right, so any command you passed in and all the arguments, and that gets output, and then I put a little banner at the end saying that, okay, that was your end of your output, and I passed that to netcat. So it's really pretty simple. What about sending files? So I have the listener on the forensics workstation that's listening for a file name. So when it receives a file name, it creates a new listener to receive the file data, and it redirects the file to the one with a correct name. Right? So there I don't want to keep a live listener, right? I want a listener that's going to get the file, and when I get to the end of the file, I want that listener to go away. Right? So on the client side, I will send the file name. I will pause just a little bit. I probably don't really have to, but I would rather pause for a few seconds and know that it's going to work than risk that, maybe occasionally I try to send something too soon and the listener wasn't spooled up yet. So here is the file listener, and if you call it, you need to give it a file. And all it does is it creates a file name listener. Notice that this one doesn't have the keep alive switch, and I have a little do loop. It's an infinite do loop. And as soon as it exits that first line, that means that somebody sent me something, right? So it's going to drop into the next line where I create another listener on port 5556, and I redirect everything to my file. And then what it's going to do is it's going to go back to the top and create another listener for a file name. And it works pretty well. It's like the poor man's FTP, essentially. What about the client side? All right, so on the client side, these first couple lines are just defaults for testing in case I didn't, set up that other stuff that I showed you in a previous script. And it's easy. I just say call the script, give it a file name, and it says, did you give me a file name or not? If you didn't, I'm going to give you usage. I log it to my little log file, and then I send it across. And here's where I wait. I sleep for 5 seconds just to make sure everything is up and going on the other side, and then I send the data. When I'm done, I want to clean up. So how do I do that? I want to close all of these listeners, close the case file. So here's my script for that. I just say, hey, let me record in my log that I shut this down, and I just use kill all on start case, start file listener, and then finally I do a kill all on netcat, because occasionally you might have a little netcat listener that's kind of orphaned out there. Right? So this just kind of cleans up. Okay. So that's some of the technical details. It's not really sophisticated scripting, but it works. So let's talk about collecting data. So what data do you want to collect and why? Right? The first thing you want to get is the date. Why do you want that? Well, because there can be a clock skew on the subject system. Right? As most of you probably know, most computer clocks suck. Right? They are horrible at keeping time. What's the only thing that keeps them sort of accurate? Is a time server, and not everybody uses those, right? Some people block time servers. I used to work at University of Redacted, where they blocked, yeah, I see Freddie's like, yeah, for University of Redacted, good old University of Redacted. Anyway, they blocked time servers. It's like, oh, you can't go out on the internet and get the correct time. Sorry, we block it. You might also have a different time zone. Maybe the time zone's messed up. Maybe the time zone is different from your time zone. Then you want to collect the kernel version using uname-a. Right? This will tell you exactly what kernel is being run, and you can check that kernel for any known vulnerabilities. Other things you want to collect. What network interfaces are on this machine? So you can do an ifconfig-a, and you can say, are there any new interfaces? Are there any strange addresses being assigned to my interfaces? What are the network connections like? You can run netstat-anp, and you can check for suspicious internet addresses that are being connected to. It's like, hey, I'm here in Grand Rapids, and my machine's talking to Russia a lot. Shouldn't be doing that. Okay. Are there any strange localhost connections? Sometimes attackers will start services on the local host because most IDS and IPS systems don't look at those. Right? They only look at the real network interfaces. Are there any suspicious ports? Are there any programs running on the wrong ports? You know, a lot of people might try to run malware on port 80. Why port 80? Who blocks port 80? Not many people, right? Yeah. Yeah, University Redacted. Exactly. Yeah, they probably block it. I know they block it, actually. But. So, more things you might want to collect. You want to look at what files are open. So you can use lsof-v. That's capital V. It gives you some nice verbose output. So you can see what programs are using certain files and ports. And if you have malware on your system, in general, if any of these commands fail a lot, that's a good indication of malware, right? In the Windows world, you run a command, it fails, and you're like, it's Windows, right? But most Linux users, they run something that fails, they go, oh, I'm suspicious, right? They don't just go, I'll just reboot. Let's reboot and see what happens. So, yeah, you might see this fail. And this is actually a very common command that does fail when you have malware on a Linux box. What running processes are there? Run a ps-ef, which will give you a full listing of everything. You might also like ps-aux. It's a slightly different listing. You can run them both. It's okay. You know, electrons are cheap. You can run both of them. Are there things that are running as root that shouldn't be? Are there accounts that shouldn't be logging in that are logged in and running stuff? Again, this might also fail if you've got some malware on that system. What about routing information? You can run a netstat-rn, and you can also run route. I recommend that you run both. If they differ, that's another pretty good indication that you've been hacked, right? If they don't run, you've been hacked. You guys sense a theme here? So things don't run, you've been hacked. Things don't agree, you've been hacked, right? Also, you can look for things that are routed through a new interface. Has one of the interfaces become the default when it's not normally that way? Are there new gateways in your network? What about mounted file systems? You can run mount and see if there's anything new. You can also run df, disk free. You might think, why would I run that? You get slightly different information. And again, sometimes people will alter the information for mount and not for df. Also, df will show you file systems are filling up, which might be another indication that something bad has been happening. Sometimes, depending on the file system, the mount options might matter. You might find that the mount options have been changed. Again, disagreements equals malware. Some other things that you might want to look at, you can create temporary file systems. And these are used a lot in some Linux systems. In fact, in some distros, by default, /tmp is actually a temp file system. So when you reboot, it goes away. Right? So if I was a hacker, a bad hacker, that is, I might want to store stuff on a temporary file system so the evidence goes away on a reboot. By the way, I will give you this little hint. If you're looking for pictures for your slides, be very careful when you use Google Images to look up mounted. You'll get a lot of very interesting and sick photos. But all right, so kernel modules. What kernel modules are loaded? You can use lsmod to list them. Are there new device drivers? Did somebody change any of the modules? Are there just strange modules that you've never seen before? Who's logged in now? You can run the W command. Some of you might be familiar with the who command. W is the same thing, except it also gives you the command line that was last run by that user, which is yet another reason you should not be entering your passwords on the command line, right? Some databases, etc., have an option where you can be lazy and not type in your password at a prompt. You know, maybe you want to put it in a script. Hey, that's a great idea. Secure the data at rest. Plain text passwords and scripts. So, yes, I can run W and I can get the full command. Not just what they ran, but exactly what they ran, including any parameters. I can see who's been logging in lately using last. You know, are there any system accounts that shouldn't be logging in that have been logging in? Are there accounts that don't normally log into this machine? You know, maybe it's a dev machine and I've got Bob from accounting who's logging in. Are there any failed logins? That's where the last B command can help you. So if you see repeated failures and then a success, right? So I run last and I see that someone logged in at a certain time. And before that, I see 30 failed login attempts. What does that tell me? Someone's got a bad password, right? If I only see 30 attempts, that's like, hey, oh, you're in the top 30 of bad passwords. Congratulations, right? So that tells me that someone's password's been cracked. And finally, user login information. So I probably want to send Etsy password and Etsy shadow along. I want to look for any newly created logins. Right? Not everyone will do this, but some people will use system tools to create a new login. And so where's that new login going to be? Right at the bottom of these files. It's like, oh, there's nothing. Oh, look, there's a new one. Right? Looks a little suspicious. Are there system accounts with shells? Again, things that shouldn't be logging in that suddenly have a shell in a home directory. Are there accounts with ID 0? Right? A company where I once worked, I had a sysadmin tell me this story, which I can only go on what he said because I surely have zero knowledge of what actually happened in this case. But he said, hey, Phil, we got this strange thing. There's this new account called Nobody that showed up in our domain here at this company, and it's got user ID of 0. I'm like, really? You don't say. That's kind of interesting. Wonder how that happened. But so, of course, what did that mean? You had someone with root access, right? They created a new account, gave it user ID 0, gave it a name that sounded kind of like generic, like nobody or no one, something like that. And sure enough, from what I remember, the sysadmin told me, of course, I have no personal knowledge of what happened here. That account was out there for a good 6 months before anybody noticed it. Now, I suspect, using my detective skills, what might have happened is that, say, a sysadmin left themselves logged in as root on a console, and they actually had the root login for the entire NIS domain, across the system. They weren't using local root logins. So they had one root password for the whole frickin' domain. So I suspect, but I can't prove, because again, I have no personal knowledge as to what exactly happened here, that someone noticed this root shell and created this account. And like I said, we're around 6 months, nobody noticed it. So look for stuff like that. Accounts with passwords that shouldn't have passwords. Do you have system accounts that don't log in and suddenly they have a password? Why do they have a password? Doesn't make any sense. So how do you put all this together? You can put it together in one big happy script, and that's all I've done here is I have the script. It's like my initial scan script. And all I do is call my sendlog script and I run all the commands I just talked about. Right? By the way, who else loves this t-shirt? I don't know if you can read it. It says, "Go away, or I will replace you with a very small shell script." I thought it was hilarious. So here's what it looks like when you run that script. All right, so here, again, I've mounted my known good binaries, and I have my known good bash shell running, and I'm just going to run this script So I'm on my forensics workstation. I started a case. I ran PS. You can see some of my netcat listeners and other associated files and processes. I source my little setup script where I set those parameters, and I give it the IP of my forensics workstation. I run my initial scan, and boom, I'm done. Scan's already done. Right? So that was easy. So now the question is, well, I guess I should probably look at the log file. I know that's kind of like, who looks at the log files? So many people log stuff and never look. All right, so I'm still trying to ask that question. Have I been hacked? Well, I'm running netstat, and what happened? What's my output from netstat? Nothing. I run lsof. What's my output from that command? Nothing. It's looking pretty bad, isn't it? Right? It's looking kind of likely that I've been hacked. Who's John with two N's? So if you look at the highlighted portion, you'll notice that there is a user, a legit user, John Smith, and I see this John with two N's, and it almost looks like someone tried to impersonate the first user, didn't they? Right. And check out the home directory, home/.john, and then their shell is bin bash. Right. So why would it be .john? It's a hidden file, right? So that's another thing that I might want to look at later. But again, right now, we're just trying to do triage. We're trying to say 15 minutes or so, did someone hack me or not? Should I go further in this investigation? All right, why do these accounts have passwords? Whoopsie. Whoopsie has a password. That's a little strange. LightDM. LightDM is a display manager for my GUI environment. This is a system account. Why would it ever have a password? That doesn't make any sense. Who's been logging in lately? John with two N's been logging in. Oh, and look, his good old buddy, LightDM, has been logging into my system. And I see that John with two N's has logged in multiple times. And I can note, when did this occur, right? This can tell me about when a breach might have occurred, and that will help me when I start doing my later, dead analysis, etc. Who failed to log in? Oh, your attacker screwed up at least once. He tried to set up this LightDM account to be able to log in, but I don't know if he fat-fingered the password, or maybe he didn't get the shell set up correctly, or some sort of problem prevented it from logging in. All right, so it's looking pretty good that you've been hacked. Right. So now what are you going to do? Well, this is kind of my high-level incident response. So the first thing is, somebody called you. You said, was there an incident or not? And if it wasn't the case, you're going to document, why did they think so? And you put that in your knowledge chest of lessons learned. So in this case, you're pretty sure there was an incident. Now you can decide, do you want to do live analysis or not? And then dead analysis. You know, sometimes you want to do that, sometimes you don't. And of course, everyone's favorite is the writing reports part, right? They're always trying to avoid that one. It's like, oh, Bob, that can be your job. I'll do all the fun stuff. So if you are doing live analysis, you know, in some cases, you might actually skip the live analysis. You might kind of just go straight to dead analysis. But if you do want to do live analysis, you can use these same kind of techniques. You can grab some file metadata. I have some little scripts. All these scripts are available for download on linuxforensicsbook.com. So again, not trying to sell you anything. They're all open source. And you can grab things like the user's history, some log files. You can get hashes of suspicious files. You can dump the RAM. Now, any of you use volatility? Who's used volatility on Linux? Okay, a couple of you. So you probably know that you have to compile a program called LIME, the Linux Memory Extractor. Do not compile stuff on the subject computer, right? Especially this guy, right? So it's a really bad idea. Again, remember one of our rules was you don't write to the subject media. Well, don't compile stuff on that computer because you're going to use a lot of memory and write to the media. So compile it on your forensics workstation. There's some pretty easy ways to do that. It's also, you know, you should know that it is a little bit risky when you run LIME. There's always the chance that the system will just straight up crash. So I do recommend you might want to collect some volatile data like the network information, etc., before you run LIME, right? And then you can compare those results as well. You might want to do some traditional dead analysis. In most cases, unless you just cannot take that system offline, it's a lot better to do dead analysis. It's just so much more mature and there are so many more tools available to you. However, if you can't shut down that system, you can still get a file system image with DCFLDD. Who's familiar with that tool? I better see at least 30 of you say that, yeah. So DCFLDD, if you're not familiar, is just a forensically enhanced version of DD, your old good bit pushing friend. And it will allow you to get an image of a running file system, a live file system. You might not be able to use that in court. Sometimes you don't care. Right? If you can figure out what happened, and then you can find other evidence that you can use in court, that's still good. Right? As I said, it's a lot more mature. One thing I will warn you about, volatility is a somewhat new tool, and Linux support is new to a new tool. And as a result, I found that it falls down a lot. If you're running a recent Linux kernel, and I don't mean just a 4.0 kernel, I mean if you're running a later 3.16 or higher kernel, I've seen that a lot of the volatility modules just fall on their butts, right? Also, I have not found anyone that could point me to a single incident where something they discovered from a memory dump wasn't also discoverable somewhere else. So again, you know, sometimes you might hear people just debating, can I even use things from volatility as part of my case? And, you know, I would say, why not? But in addition to that, you will almost always, I mean, I have not seen a counterexample, at least, I'll say that, find the same evidence somewhere on a file system or other place that you can say, I've got some good mature tools that prove that this happened. All right, so if you wanted to find out some more, I heard a rumor that there was a new book out. It had cool cover art and everything. Other things, as I said, there's some good resources. All of them are free. You can download some videos and also some of these scripts from linuxforensicsbook.com. Feel free to come talk to me later. And with that, if you have any questions. Yes, sir. So you're concerned about using unencrypted stuff to push it over the network? Yeah, always if that's a concern, you could encrypt it. There is a small concern that that's going to increase your memory footprint on the subject system, but sometimes it makes sense. Now the other thing I would say is, what's the best situation? Let's say I'm going to the subject system. If I can physically touch it, I could probably do something like, connect a crossover cable to it if it has an available network port, and then I don't have to worry about that so much. But yeah, that could definitely be a concern. Yes, sir. I don't have a book on that, no. The question was recommendations for mobile forensics, and offhand, nothing's coming to mind. You're correct. Things like Android. Android is sort of like Linux, but not exactly. And I think the other thing is there's not an equivalent that I know of, like for volatility memory analysis for Android yet. Also, the file systems used on your Android device are not going to be like ext4 file systems in most cases, so a little different. All right. Anyone else? Well, thanks for staying alive, till 3 o'clock on a Saturday afternoon.